Good morning everyone. So recall that in the last class we were discussing inclusion exclusion formula for mainly two sets and three sets. Today we will see the generalization of inclusion exclusion formula. To start with, the first notation is that the intersection sign is there. So if I write A1 intersection A2 intersection A3, it simply means A1 A2 A3, or A1 A2 A3 means A1 intersection A2 intersection A3. So now I am looking for n of a1 bar, a2 bar, an bar. So if you generalize for two sets and three sets which we have discussed in last class, then n of a1 bar, a2 bar, an bar can be written as n of n minus s1 plus s2 minus s3, where s1 is you sum all of n i's, s2 you sum all of ai, aj, and so on. Yes, and the corollary says that n of a1 union a2 union an is n minus, it is n minus n of a1 bar, a2 bar, and an bar. That gives you s1 minus s2 plus s3 and so on. So let's see some exercises. The first one says that how many ways are there to select a 6 card hand from a regular 52 deck such that the hand contains at least one card in each suit. So to apply the inclusion exclusion principle, first try to identify, or first see that you are looking for n of a1 bar, a2 bar, and an bar. So what could be your ai bar? So my ai bar would be the set containing at least one card in each suit. So containing at least one card in each suit. It means your ai is no card from particular suit, or if they are, so now we know that there are four suits are there. So 1 2 3 4. So ai represents that no card from suit I if there are four suits. Yes, so it means that my n is to pick 6 card from 52 cards. Then n of ai is, I cannot, for example, I cannot pick the card from third suits. So remaining cards are, each suit has 13 cards, so remaining are 39. So out of 39 I have to pick 6. Then if two suits are not allowed, then there are 26. If 3 are not allowed, then there are 30. Yes, it means that n of a1 bar, a2 bar, a3 bar, and a4 bar is n minus summation ai. So 4 sets are there, so 4c1 and 39c6, and here is 52c6. This is 39 plus 4c2 because I am taking two sets at a time, 20c6 minus 4c3, 13c6. So this is the required answer. The second part says that how many 6 card hands with a void in at least one suit. It means that I am looking for a1 union a2 union a3 union a4. This is because a1 represents that the first, there is a void for the first suit. a2 represents there is a void for second suit, which means it is not available. But it may be possible that when at least one is not available, it means all four are not available or three are not available. That's why we consider the union, and it is simply s1, so 4c1 39c6 minus s2 plus s3, which is the required answer. How many ways are there to distribute R distinct word is there, objects into 5 different boxes with at least one empty box. Yes, so now how many boxes are? 5. So AI represents that ith box is empty. So at least one empty box, it means I am looking for the union of all AIs. Yes, which is S1 minus S2 and so on. Now S1, or if I talk of n of AI, it means the ith box is empty. It means I have to distribute R distinct objects into 4 boxes. It can be done in 4 raised to the power R ways. If 2 boxes are empty, then we need to distribute in remaining 3. If 3 boxes are empty, then remaining 2, and if 4 boxes are empty, then in the last one. So it means that S1 is 5C1 4 raised to the power R minus 5C2 3 raised to the power R plus 5C3 2 raised to the power R plus 5C4 1 raised to the power R and plus 0. 0 because all the boxes are empty. So n of A1, A2, n of A1 union A2 union A3 union A4 union A5. Moving further, let's move to the next question, which says that how many integer solutions are there to this equation. So we did this question using the generating function, but if I have to do it inclusion exclusion, I must remember what does it represent as a combinatorial problem. So it says that the number of ways to distribute 20 identical balls into 6 boxes such that each box has at most 8 balls. So it means my AI bar is ith box has at most 8 balls. It means AI is ith box has at least 9 balls. Yes, and all the balls are identical. So if I have to compute n of AI, it means ith box has at least 9 balls. I first put the 9 balls into, first let's compute n. So n is distributing 20 balls into 6 boxes. So R plus n minus 1, so 20 plus 6 minus 1, and R, so instead of 20 I can write 5 also, which is same. So this is 25C5. Now in case of AI, if I put 9 balls already, then the remaining balls will be 20 minus 9 plus 6 minus 1 5. N of AI AJ is 20 minus 18 plus 6 minus 1 5. Yes, because two boxes have at least 9 balls, so 18 are already, we put 9, and the remaining balls we distribute in all the boxes. And if I compute n of AI AJ AK, then it would be 0, because 20 minus 27 plus 6 minus 5, so it would be 0, and so on. It means that my n of union AI is S1, which is 5, which is 6C1, because 6 boxes are there. Sorry, it is not union, it is intersection. So n of intersection AI bar, so it is n minus, which is 25C5 minus 6C1 n of AI, which is 1611, so this is 1611 plus 6C2, and this is 7C5, so 7C5. Yes, so either you write 16C11 or 16C5, both are same. You write 7C5 or 7C2, both are same. The next one is very interesting problem and little bit difficult. It says that how many ways are there to color 4 vertices in the graph shown in figure below, such that the vertices with a common edge, so edge means a line, with a common edge must be different color. It means if there is an edge between x1 x2, then the color of x1 and x2 must be distinct. They cannot have been same color. So the first thing is to identify AIs here. Yes. So what I am looking for, if there is an edge, then endpoints must have the different color. So if I say AI bar, then I say that endpoints of edge EI must have different color. Yes, it means my AI must be endpoint of edge EI, endpoints of edge EI must have same color. Yes, this is very important. If this is done, then the further calculation are not very difficult. Clear? So now there 5 edges are there. It means I have to compute n of a1 bar, a2 bar, a3 bar, a4 bar and a5 bar. Now I start with n. So n means the number of the ways to color 4 vertices with n colors. So 4 vertices are there, each one has n choices, so n raised to the power 4. Now let's start computing n of AI. So if I compute n of AI, what does it mean? It means ith edge, the endpoints of the ith edge must have the same color. For example, if I choose E5, then I say that x3, x4 must have the same color. There are n choices for x3 and the same color would be used for x4, so in total n choices. And for each of the remaining one, x1 and x2, there are n choices because they can be same different, I don't bother. It means n of AI is n cube. If I consider n of AI AJ, if you try by yourself, you realize there are two possibilities. The one possibility is that, let me choose for example E1 E2. So if I compute n of E1 E2 or A1 A2, so for A1 A2 3 endpoints are covered, x1 x2 x3. So x1 x2 x3 are covered, so n choices. If I use n choices for x1, the remaining should have the same color, but then x4 must have the different color. Yes. Now if I choose the two edges as instead of a1 a2, if I choose let's say e1 e4, then what will happen? The endpoints are x1 x2 and x1 x4. And if I choose the non-adjacent edges, which means their endpoints are not common, for example a2 a4, so in case of a2 x2 x3 are the endpoint and x1 x4 are the endpoint, n choices for this one and n choices for this one. So two different cases are there. Of course in both the cases answer is n square, but we need to discuss both the cases. So n of AI AJ is n square. Now if I have to compute n of AI AJ AK, then again there are two choices. The first choice is, if I consider n of A1 A2 A3, so you can see that the endpoints covered are x1 x2 x3 n choices and x4 n choices, which is n square, and it is equal to n of A1 A3 A4. In both the cases I will get n square. But other than this, if I try anything, for example, if I choose n of a1, a2, a4, so a1, a2 and a4, so you can see that all the endpoints are covered. In all other cases, all endpoints would be covered. It means first one has n choices and the remaining would be given the same color, so it's n. It means n of ai, aj, ak, so there are 5 edges, so 5c3 minus 2 have n colors and 2 have n square. If I choose n of ai, aj, ak and ar, then all 4 edges, you choose any 4 edges, they cover all the vertices, so n choices. And similarly n of a1, a2, a3, a4, a5 again would have the n choices. It means my n of a1 bar, a2 bar and so on, a5 bar is n, which is n raised to the power 4 minus 5c1 n cube plus 5c2 n square minus, it is 2n square plus 5c3 minus 2n plus 5c4n minus n. If you simplify, it becomes n raised to the power 4 minus 5n cube plus 8n square minus 4n. This is also the final expression which I got in n. It is known as the chromatic polynomial of the given graph. So that's all from today's class. In the next class, we will discuss the concept of dearrangement. Thank you very much.